For number 5, adding polynomials, I'm looking to see what is the highest exponent that I have. And I see that I have an 8. This 5b has an exponent of 1, 6, and then 1 again. So the highest exponent that I have is an 8. Now, this term cannot combine with anything else because it doesn't have an 8 on any of the other b's. So this will be 6b to the 8th. And then going in descending order down, we've got 8, then we have a 6, and as I can see, that cannot combine with anything. So I bring that down as well. And then lastly, your negative 5b can combine with 9b, and negative 5 plus 9 would be positive 4b. Okay, in number 6, it's also adding polynomials. So here, we're going to start with that highest exponent again. In that case, it is a 2. And I have 2 of those. So those 2 can be combined, and we would get 8x squared. Then, going in decreasing order, we would have 3x and 2x, and that would make 5x. And lastly, a negative 3 plus 8 is a positive 5. Okay, in number 7, it says to subtract polynomials. So for this one, we need to change that to a negative 1. And we would change all of the signs in the second set of parentheses. So the first part will stay the same. And then change these signs to be the opposite. And we would go same thing. Look for the highest exponent. It looks like a 2. I have a 3. So I'm going to go with this first. And put down negative 2x to the third. Then I have 4x squared. And that would just be positive 4x squared. Then I have negative 5x minus 6x, and that would give you a negative 11x. And then lastly, your 7 and 8 would combine to be 15. So as you can see, I went in decreasing order or descending order. So 3, 2, my invisible 1, and then no x or exponent at all. Okay. For number 8, it says that we have to multiply polynomials. So on this one, I went ahead and gave you the box there if you need it, the box method, basically what you guys would call a Punnett square, but we know it's not a Punnett square in algebra. We would put this here, x and negative 5, and then x and 7. So we're going to say x times x is x squared. X times negative 5 would come together to be negative 5x. 7 and x would be 7x. And then 7 times negative 5 is negative 35. So x squared and the negative 35, they have nothing to combine with. So they're at the ends here. But we see that the 7x and the negative 5x, they're on the diagonal. They combine because they have the same variable with the same exponent, x to the first, x to the first. So if I combine them, 7 minus 5 would be positive 2x. In number 9, same thing, I need a label. So I've got x and 8, x and negative 8. So x times x is x squared. 8 times x is 8x. X times negative 8 is negative 8x. And 8 times negative 8 is negative 64. So again, I've got the x squared. We see that 8x minus 8x, this gives you a 0. So I'm not going to have to write anything down for that. And then I would bring that negative 64 down. Okay, in number 10, we can label the 4x and the negative 3 on the side here because there's only 2 spots, and that's a binomial, or 2 terms. And then on the top, we've got 3 terms, x squared, 3x, and 7. So we're going to do a lot of multiplying. We've got 4x times x squared. That's going to be a 4x to the third. Then 4x times 3x becomes 12x squared. So those came together. And then 4x times 7 is 28x. Down here we have negative 3x squared. Then we have negative 9x. And then negative 21. All right, so first, the 4x to the third, it doesn't have anything that it can combine with, so it's the first term. Then looking at the diagonal, right here, they both have x squareds, which they should, and that would be 12 minus 3, which is 9x squared. And then we have 28x minus 9x. Again, both have an x on the diagonal, and that would become 19x. And then lastly, negative 21, it doesn't have any other terms it can combine with, so I just bring it down at the bottom. Okay, the last two for this page are dividing polynomials. So here we discussed that we would divide the big numbers there, 20 and 2, 4 and 2, and negative 10 and 2, but then we would subtract exponents. So 20 divided by 2 gives me 10. Then I have an x, so 6 minus 2 is 4. For y, 3 minus 1 is 2. Then I divide again, and we have 4 divided by 2 is 2. 4 minus 2 is x squared. And then for my y, 2 minus 1 is 1. But again, we don't need to have that 1 written there unless you really want to. Negative 10 divided by 2 is negative 5. And then 3 minus 2 is x to the first. Again, we don't have to have that 1 there. And then 1 minus 1 is 0, so I don't write that at all. Okay, so that would be my final answer for number 11. And then in number 12, you bring the monomial right here underneath the trinomial. We can kind of get rid of it because we don't need it now. And we're just doing the same thing. We're dividing, subtracting, etc. So this would give us 3x. 3 minus 2 is to the first. 12 divided by 3 is 4. 2 minus 2 is 0, so I don't write that down. 21 divided by 3 is 7. And 1 minus 2 is negative 1. And we discussed in class that we can't have a negative exponent. So we need to put this as a fraction and bring this to the bottom of the fraction, making it a positive 1. Make sure that you get rid of that negative. Okay, so this is how your final answer should look.